video, I would like to introduce a very nice problem regarding arithmetic and number theory. Here is the following setup. We have a and b as a natural number. We have the following equation: a plus 14b equals 7ab. Okay, so the question, do a, b satisfy this equation? Which means, do we have a solution for this equation? Okay, so first of all, while we are working on this one, we are going to prove these both facts. First fact, we have a GCD of these integers m and m minus number 2 equals 1 if m is odd, equals 2 if m is even. They differ by number 2 here. The other one, they differ with number 1. So the GCD of the second one, GCD of the second one equals 1. Now let's go through the proof. Let's prove this one. So for this one, let's set d equals GCD of these two integers, m and m minus 2. Okay, we say in GCD, which means we have a common divisor for both integers. We say in d divides m, equivalent m equals k1 is multiplied by d, where is a k1 is a some natural number, and d divides m minus 2, equivalent m equals m minus 2 equals k2 is multiplied by d. Okay, I'm going to take the difference of these two integers. I get m minus 2 equals k1 minus k2 d, which equals k is multiplied by d. So this one, by cancelling out m, I get 2 equals k is multiplied by d. This one is starting as d divides number 2. If d divides number 2, since 2 is a prime, which means since 2 is a prime, which means d equals 1 or number 2. Because we know the prime number always have number 1 as a divisor or the number itself, which is a prime itself. Okay, so we get this following. We have proven this one. We get GCD of this one. You get 1 if m is odd, which is this one. We get number 2 m if m is even, which is this one. Now let's go to the second proof, this one. We have d also GCD of these two integers m and m minus 1. d divides m, equivalent m equals d is multiplied by k1, whereas k1 is a some natural number. Also d divides m minus 1, equivalent m minus 1 equals d is multiplied by k2. Let's take the difference of these two integers. I get m minus 1 equals k1 minus k2 is multiplied by d. Okay, cancelling m, I get d divides number 1. If d divides number 1, which means d equals 1. So we have proven the second fact. Let's go to our question. First of all, we are going to solve this equation as we normally do. So we get a plus 14b equals 7 times ab. Taking this 14b to the right, I get a equals 7ab minus 14b. Taking 7b as a common factor, since we have 7 here, we have 14 and b here, which means we get 7b factor a minus 2. So if you take a look, basically we get a minus 2 here, which this one is similar to our proof that we have here before, because that's the reason why we have proven this one. We know a cannot divide a minus 2 if a is an odd, as we have here. If a is even, it will be different because their GCD equals 2. That's why we are going to take two cases now. Let's do the case number 1. If a is an odd, which means the GCD of this integer a and a minus 2 equals 1, which means a cannot divide this one, which means a divides 7b. Okay, since we have GCD of the a and a minus 2 equals 1, because they are comprime in this case, which means A must divide 7B. Okay, if A divides 7B, which means according to the divisibility statement, I get 7B equals A is multiplied by K, where is a K is a sum natural numbers. Okay, replacing 7B with AK here in this equation, I get A equals AK is multiplied by A minus 2. Since A is a natural number, I'm going to cancel out A from both sides because A is different than 0. A is always different than, always A is superior to 1 and B is superior to 1 because they are natural numbers. Okay, so now we are allowed to divide both sides by number A. So we get here number 1 equals this product equals K is multiplied by A minus 2. Since the product of these integers equals 1, which means number 1 is going to take K and is going to take A minus 2 as well. So I get here. So I'm going to take this one, A minus 2 equals number 1, because we don't need K in this case. We need A as a solution. We don't need K. K equals 1, K as arithmetically equals 1. So taking this minus 2 to the right, I get A equals number 3. Now I found the solution for A, but the problem, let's see, we have a solution for B. By taking this value of A and plug it into the original equation to see what's the solution. I get A, which is 3, plus 14B equals 3 is multiplied by 7, which is 21, is multiplied by B. Now we get 14B here, we get 21B here. Moving over 14B to the right, I get the difference equals 7B. Okay, so which means 7B equals 3, which means B equals 3 over 7. But this one is not integer, which is we have no solutions for this equation over odd integer. Let's move forward to the second case. Previously we have shown we have no solutions when we have A is odd over integer numbers. Now in this case we are going to discuss this situation when we have A is an even integer. Okay, so simply we know A is an even, which means let's set A equals to 2C. Okay, replacing the same value of A into the original equation to see what's the status of this equation. So I get here 2C equals 7B is multiplied by 2C minus number 2. So we get number 2 here, we get number 2 here, we get number 2 here, which means we are going to divide both sides by number 2. I get here 1, I get here C equals 7B factor C minus number 1. So we fall in this one. Look, M minus 1 as a GCD, we get C minus number 1. Because C and C minus number 1, their GCD equals 1, which means C and C minus number 1 are comprime integer. Okay? So that means C cannot divide this one. Since C cannot divide this one, which means C can divide this one. Okay? So since GCD of C and C minus number 1 equals 1, this one implies C divides 7B. Okay? This one is telling us 7B equals K prime, for example, is multiplied by C. What is a K prime as a natural number? So taking the same value that I found now and replace it back into the original equation. So I get here K prime C factor C minus number 1. Since we get C at the left hand side of this equation, we get C at the right hand side of this equation as well. Let's cancel out that because they are integers. C because as a natural numbers. So this one is telling us number 1 equals K prime is multiplied by C minus number 1. We get the same thing as we have found before. So this one is telling us C minus number 1 equals 1, which means C equals 2. after taking minus 1 to the right, I get c equals 2. If c equals 2, which means I'm going to find b here, okay? So this one is going to give us c equals 2, 7b here, c minus 1, which is 1. I get number 2 equals 7b, okay? It's clearly, it's a contradiction. Impossible. Because you cannot have the product 7b equals number 2 here, okay? B is not the integer number, okay? So we have proven both cases. They are not satisfy this equation, which means we have no solutions for this equation, over natural numbers. So I have done with this problem. By the way, don't forget to hit the subscribe button and support the channel. And thank you for watching. I will see you in the next video. Bye.